Today's lesson is on applying exponent laws. So before we get started in what the laws are, you need to know that in order to apply any of these laws, your base, so in this case, all of our examples are given in X, must be the same. If they are not the same, these laws cannot work. So we have a product of powers law, which means if I have two bases that are the same, in this case X, I can take their exponents and add them together to create one term. Quotient of powers works similarly, only because I'm dividing, I can now subtract my terms, given that x does not equal 0 because we can't divide by 0, okay? I have a product of powers rule, which means a term to a power, in brackets, to another power, means I can take the two powers and multiply them together to create one term. I can also have a power of product rule, which means if I have two numbers that are being multiplied together, I can distribute that exponent to both of them so long as they are in brackets. If it's not in brackets, it doesn't work. So a power of a quotient is if I have two numbers that are being divided, similarly to the ones that are being multiplied, I can distribute that exponent to both of them. In this case, y can't equal 0 because we can't divide by 0. However, if they are not in a bracket situation, this cannot work. So let's go through a couple examples of this. So here we want to simplify by writing as a single power. So I have 0.8 squared times 0.8 to the negative 7. So in these notes, the little dot means multiplication. I'm going to apply my product law, which means I'm going to add my exponents together. So I'm going to have 0.8 squared plus negative 7. So negative 2 or negative 7 plus positive 2 is going to give me 0.8 to the negative 5. And I'm going to now have to express this as a positive power. We don't like to leave powers as negative powers. So in order to express this as a positive power, we're going to use our reciprocal law, and I'm going to write it as 1 over 0.8 to the power of 5. Now this is where we will leave it. This is what our answer is. This is what we're going to be left with, and that's okay. Example number 2. I am going to go through and I'm going to multiply my two powers together within this term. So I have 2 times negative 3. I'm going to be left with negative 4 over 5 to the power of negative 6. And I'm going to divide that by negative 4 over 5. And I'm going to take 4 and negative 5 and I'm going to multiply them together. So we're using the power of a power law, and I'm going to get negative 20. Now, both of these have negative exponents, but we're going to deal with that after the fact because maybe we won't have to worry about it. Now I'm going to subtract my exponents, so I'm applying a quotient law because I'm dividing two. They have the same base of negative 4 over 5 and negative 4 over 5. I can subtract my exponents, and I'm left with negative 4 over 5 to the negative 6 minus negative 20. So if I take negative 6 minus negative 20 into my calculator, I'm going to wind up with negative 4 over 5 to the positive 14. So in this case, I have two negatives make a positive number. So it's like taking negative 6 and adding 20. Okay, if that's confusing to you, we might need to look at a couple other laws before we can keep going. So just let us know if that's something that you're not sure about. Example number 3, I'm going to start by using my power of a power law on the numerator. So we always want to deal with things when we're given fractions in sections. We want to deal with everything we possibly can in the numerator, everything we possibly can in the denominator, and then deal with them together. So we're going to use a power of a power rule, and I'm going to have 1.5, and I'm going to go negative 3 times negative 5 all over 1.5 to the power of 5. Now negative 3 times negative 5, once again, two negatives make a positive. I'm going to wind up with 1.5 to the power of 15 all over 1.5 to the power of 5. Now when we're looking at this, I'm going to use my power, like subtracting my exponents, so my quotient law. So I'm going to wind up with 1.5 to the 15 minus 5, which is going to give me 1.5 to the power of 10. This is my final answer, so we're going to leave it at that. Example number 4, here we go. We are first going to start with the numerator, and we're going to add our exponents together. So I'm going to wind up with 9 and 5 over 4 plus negative 1 over 4. Now, when I'm adding fractions, we have to make sure our bases are the same, and we just add our tops. So I'm going to wind up with 9 times 5 plus negative 1 is going to give me 4 over 4. Now, we are going to have to deal with this denominator again. So I now have 9 to the power of 4 over 9 to the power of 3 over 4. I can use my quotient rule. I'm going to subtract those two. So I have 9 to the power of 4 over 4 minus 3 over 4. And I'm left with 9 to the power of 1 over 4. And we can leave this, okay? This is fine. It's not a negative. We're going to leave it as 9 to the power of 1 over 4. Don't really want to mess with my radicals and things like that right now. If you're just asked to simplify it to a single exponent, make sure it's positive and you can leave it as a fraction. Now we're going to simplify the following expressions. When we're simplifying expressions, we're doing the exact same thing as we did before. So in this case, we're going to add all exponents of m as our first step because we have two separate bases here. M is a base and n is a base. So we're going to add all our exponents of m, and I'm going to be left with m to the power of 6 because 4 plus 2 is 6. And n, now we're going to add all our powers of n. I have negative 2 plus positive 3 is going to leave me with n to the power of 1. I am now going to leave this. It is fully completed. We can do nothing more to it. Number 2. I have 6 times x to the power of 4, y to the negative 3 divided by 14x, y to the power of 2. So first things first, we're going to deal with our exponents of x. So I'm going to have x and I'm going to subtract them because we are dividing. So x 4 minus 1, I'm going to be left with x to the power of 3. And y, I'm going to also subtract my exponents. I have negative 3 minus 2. I'm going to be left with y to the negative 5. Now, I'm going to deal with my fraction here. So we currently have something that looks like this, x to the power of 3, y to the negative 5 over 14. So now I'm going to deal with the numbers that I've been given here. I've got two numbers, a 6 and a 14. I want to reduce those to the smallest I can possibly make them. So I'm trying to figure out what number goes into both 6 and into 14. I can divide both of those by 2, so I'm going to remove a 2 from both of them, simplify it to 3 over 7, x to the 3, y to the negative 5. Now I have a negative exponent in my y value, and I don't like that negative exponent. So we're going to flip it to the base, so I'm left with 3x cubed over 7y to the 5. Now everything has a positive exponent. Everything is in simplest form. We're going to leave it. This here becomes your answer. You don't want to leave it as a negative 5 because it's just not nice to look at and it's not nice to work with. Example number 3. We are going to first use our distributive property, and we're going to distribute the 3 over 2 to every term within this. So I'm going to wind up with a 25 to the 3 over 2. I'm going to be left with a, and I'm going to, because now I have two exponents, I'm now going to take 4 and 3 over 2, and I'm going to multiply them together. So it's like saying 4 over 1 times 3 over 2. And then I have b, we're going to do the same thing, 2 over 1 times 3 over 2. Now we're going to leave the 25 for a second. We don't really want to deal with him right now. We're going to put these into a single exponents, and I have a 4 times 3 is 12 over 2. Remember, when we multiply fractions, we multiply, sorry, that should be a 2, not a 6. Let me erase that for you quickly here. Perfect, that should be a 2. There we go. We're going to multiply our numerators together and multiply the denominators together. So b is going to be 2 times 3 is 6, and 2 times 1 is, once again, 2. Now we're going to reduce those fractions because they can be reduced. We're going to leave the 25 once again. Nothing much we can do with him right now. And then I've got a to the power of 6, so 12 divided by 2 is 6, and b to the power of 3 because 6 divided by 2 is 3. Now what I can do is I can deal with that lovely 25 to the 3 over 2. So we're going to kind of come off to the side over here. We're going to go 25 to the 3 over 2 is like me saying the square root of 25 all to the power of 3. So I have 5 to the power of 3 is 125. So now I can say, bring that back over here. I have 125, a to the power of 6, b to the power of 3. If you want to do your little work off to the side, that's completely fine. We just draw a light little line there so I know it's a workspace. You can do the same thing when you're dealing with your exponents. If you wanted to do that math off to the side and then add them in, that's acceptable as well. All right, here we go. Example number 4. X cubed y to the negative 3 over 2 times x to the negative 1 y to the 1/2. What we're going to do is we're multiplying things together here. So I have 2 bases of x and 2 bases of y. So I've now got an x and a 3, and we're going to add our exponents because we are multiplying, plus negative 1, and a y, negative 3 over 2, plus 1/2. So my x is going to wind up being x squared, because 3 plus negative 1 gives me a 2. And my y is going to be negative 3 plus 1 is going to give me negative 2 over 2, sorry. So negative 2 over 2 can be simplified to negative 1, so I now have x squared, y to the negative 1. And I don't like that negative exponent, so we're going to have to make that a positive by flipping it, finding its reciprocal, whatever you want to call it. So I now have x squared over y to the power of 1. This is in simplest form, and it will become your exponent. Now, some of you might be wondering, well, you had 2 terms and they were being multiplied together. Why didn't you use the distributive property we used when we were dealing with polynomials? Reason I didn't do that is because if you take a quick look up to the top of the screen here, you will see that neither of these sets of brackets has an addition or subtraction sign between them. So they're not actually necessary in this case. If there was an addition or subtraction sign, you would have to distribute or FOIL like we did in the previous unit.